Hello everybody, here we are, 7.1 scale diagrams and enlargements, and I need to start very importantly with drawing a couple of smiley faces. Oh no, they're already not to scale, but you'll get the idea. Pretend this is 2 centimeters, this is 5. This would be our scale diagram and our original. And what we're learning about today, scale factor. That's a ratio between the, let's say, scale diagram and an original. And specifically, the scale factor, or I might call it SF, is equal to the length of the scale diagram over, I might call that SD, the length of the original. O. That's an O. And so if we wanted to find the scale factor, for example, of our smiley faces here, we would do the length of our scale diagram, that's 5, over the length of our original, that's 2. And so our scale factor would be, we do centimeters here, we could do this as our scale factor equals 2.5, like that. And our scale factor, for reference, even though these are in centimeters, our scale factor doesn't have units. So maybe you could write, little star, no units for scale factor. And one thing that is good to think about before you're calculating this, and often it comes up in questions, is just making sure that we're in the same units before we calculate our scale factor. So later we're going to have a question, I think, that uses centimeters and meters. So it's a good thing to check in the beginning, are you using the same units? So that can be helpful. So basically this is, we use this a lot in maps. You might use this, if you have an image and you're trying to reshape it. And often I think, I don't know if this is on a Mac or a PC, but you might have to press like Shift while you adjust the image so that it stays in proportion. So we're looking at 2 images that are proportional to each other at a certain scale. So let's do this first one. The actual length, this is good to look at keywords in here. The actual length, which suggests this is going to be our original of a needle, is 6 centimeters. And the length of a needle on a scale diagram is 9 centimeters. So what's the scale factor of the diagram? So as you recall, our scale factor equals, length of scale diagram over length of original. So here our scale factor equals the length of the scale diagram. So it says the length of the needle is 9 centimeters over the actual length. So that seems like our original is going to be 6 centimeters. So our scale factor would be 9 divided by 6. You could reduce this if you want. 3 goes into each of these. We'd have, 3 over 2 or 1.5. So like that. And remember, we should have checked. This is centimeters. This is centimeters. Our scale factor doesn't use the units. So that's it for our scale factor. The next one is kind of about looking at, we have this relationship right here? And what if it's in a different kind of order? What do we do with that? And we'll kind of be manipulating our equation a little bit to solve a different type of question. So the scale diagram of different circles are to be drawn. So we want to get to the scale diagram. The diameter of each circle and scale factor are given. So we have the original. So the diameter of each circle, that would be original. And we have the scale factor. Okay, beautiful. So we already know we know what that is, but we're looking for what the scale diagram is going to look like. So determine the diameter of each circle on its scale diagram, write the answer. So currently we have this relationship that the scale factor equals the scale diagram over the original. And if we want to rearrange this equation, we just did a little bit of this. If we want this O out from underneath, we can multiply by O on each side. And what that does for us, we cancel out those O's. And what becomes true is that the original times the scale factor is going to equal the scale diagram. And that's helpful for us because what we have the original, we have the scale factor, and we want to get to the scale diagram. So this looks like we need to multiply the original. So diameter of the original, for our first one, we got 8 centimeters, times the scale factor, times 6, is going to give us the diameter of the scale diagram, which is going to be 48 centimeters. And we do use units here because it's asking for a diameter. This is a length. Our next one, we're going to do the same. We're going to do the original 40 times our scale factor, 15 over 4. And you could cross reduce here. So before we multiply those, or you could do 40 times 15, which I think is 600. So you could do, 600 over 4, which equals 150 millimeters. We also could have cross-reduced. That'd be 1. That would be 10. 10 times 15 is 150, missed an M, millimeters. And our next ones, so you can see we're just doing this one times this one times this one. I'll use my calculator for this one. We're looking at 3.5 times 5.8. So our original times our scale factor, 20.3. That's centimeters. And our last one, our original 0.6 times our scale factor, 20.5, equals 12.3 millimeters. Okay, so we just rearranged our equation for that one. So think about how we can do that and how those relationships are true. You could test this out. You could say, is it true that our scale diagram 48 divided by our original 8 would give us a scale factor of 6? Yes, it does. So you could also check that you've done it correctly. Okay, let's do the next one. So draw an enlargement of an equilateral triangle. So we need to draw the diagram now. The triangle with side length 3 centimeters and use the scale factor of 5 over 3. Okay, so we have, remember, if we're looking at scale factor, relationship between these things equals the scale diagram over the original. We currently have the scale factor, and we have, sorry, I got interrupted. What I was saying is that we have the scale factor, we have the original, and it's a scale diagram that we're looking for. And I think there's a couple ways to look at this. We have this ratio already. We have this fraction. So we know that the scale factor equals the scale diagram over the original. Okay, so that part is going to be true. And they told us that the scale factor is 5 over 3. So if the original right here appears to be 3, then I think we can deduce from that the scale diagram is going to be 5. That our SD, this part right here, is going to be 5. I think we can kind of think our way through that. So let me show that part, that the scale diagram needs to equal 5, because we know the ratio between those two things is 5 and 3. We already know that this part is 3. But let's solve it in a different way as well. So let's also show, as you'll recall, that if we we have these two, the scale factor and the original, we can, if we multiplied each side by original, for example, that would cancel out there. And we'd have, this would be true, that the original times the scale factor is going to give us a scale diagram. So let's do that as well. Let's see if we get 5. We have the original 3 times the scale factor, 5 over 3. And you can certainly cross reduce here if you would like. Remember, this is like 3 over 1. So you could cross reduce and get 1 times 5 is 5, and 1 times 1 is 1. And lo and behold, our scale diagram needs to be 5 centimeters. And that is what we also got just by kind of thinking about it reasonably and logically. Now I'll try to draw a perfect 5 centimeter equilateral triangle, something like that. Okay, and then let's do this last one. This last one, it is important for us to point out a few things. This is when we got to read everything carefully. The dimensions of a photo of a mountain bike are 15 centimeters by 12 centimeters. This seems like this is going to be our original. An enlargement, so this is what's going to be changed to be made for a poster with dimensions 0.4 meters by 3.2 meters. So step 1, make sure the unit is the same. So we got meters, we got centimeters, we need to deal with that. So recall there's 100 centimeter equals 1 meter. So these lengths right here, the original, we're going to need to divide each of these by 100. So let's draw our original, and I'll do my best here to draw a picture of a bike. So we have our original right here. It's a photo of a mountain bike. We got, looks like this. Here's our wheel. Here's our wheel. Our handlebars and our seat. Incredible. We need to have our, the original length is 15 centimeters. We need to divide that by 100. So 0.15, meters. And the other side, 12 centimeters. If we divided that by 100, 0.12 meters on the side there. And enlargement is to be made for a poster with dimensions 4 meters by 3.2 meters. So let's draw our big version of the mountain bike. Okay, let's see. Draw your best mountain bike. Okay, where we go? A triangle and a triangle and a wheel and our fork and the other wheel and the handlebars and the seat. Incredible. Wow. And down here we've got 4 meters, 4.0 meters, and 3.2 meters at the side. And now we want to know, what is the scale factor to the nearest tenth? Well, as you recall from the very top of our notes, that the scale factor equals length of scale diagram over the length of original. So for our scale factor, the length of the scale diagram, that's this one right here. We have our scale diagram. So 4.0 over the length of the original, and we're using the same units, 0.15, should equal our scale factor. So let's do that. 4 divided by 0.15 equals 26.6 repeating. So our scale factor equals 26.67, something like that. And there you have it. So thank you so much. Make sure you have the correct units. Remember this equation here and remember how they all interact with each other. I'll give you the textbook questions. I'll let you know which ones I want you to do. Thank you so much.